Okay, homework 1.3, max min word problems. So for the area example, a farmer is making a rectangular pen for his animals. Okay, so already I'm thinking rectangle. Okay, he has 160 meters of fencing. So already I'm thinking perimeter is 160. And he needs 3 separate cages in the pen. So I'm going to do it adjacent to the smaller side. Usually it says, but that's kind of like the rule of thumb. Okay. Find the dimensions of the pen to give the animals the maximum area. So as soon as you see maximum area, we're trying to find a vertex. Okay, so in these types of questions, you need 2 things. You need an equation for the perimeter and an equation for the area. So I'm going to use x and y, and x is going to be the width. This is going to represent the width of the rectangle. Okay, and y is going to represent the length of the rectangle. Okay, so y and y. So if we were to do the perimeter, it's not just like the distance around, like the linear distance around an object. It would actually be like all 4 axes. So x plus x plus x plus x, and then the 2 y's. Okay, so I'm going to go ahead and sub in this 160 because we know what the perimeter is. 160 equals 4x plus 2y. Okay, now my other equation is going to be area, and that's just going to be x times y. So I need to either isolate for x or isolate for y and use substitution. So substitute one equation into the other. Because we're trying to maximize the area, we want to keep the area formula, so we want to substitute the perimeter formula into the area formula. Okay, looking at these, I'm going to isolate for y because 2, 4, and 160 is divisible by 2. So when we bring this over and it equals 2y, I can actually divide that out and all of the numbers are going to be really nice. Okay, so I get 80 minus 2x equals y. Okay, so I'm going to go ahead and bring this up and be like area equals x, and then we're subbing in for the y, which is 80 minus 2x. Okay, this is already in factored form. So I'm just going to branch off x equals 0. That's one of our answers. And 80 minus 2x equals 0. We're going to solve for that x value. Okay, because we have to set each factor equal to 0. And I get 40. Okay, so how does that look? We have a 0 at 0 and a 0 at 40, and it's going to look like this. Halfway between them is going to be 20. If you want to formally show that, it's going to be 0 plus 40 divided by 2. Okay, now what we want to do is we want to take our original area formula and we want to sub in that 20 to see what the area would actually be. Okay, so I get 20 times 80 minus 40, which is 20 times 40, which is 80. Okay, so the x value is 20, which is the width, right? So this width over here is going to go 20, 20, 20, and 20. And then if we want to solve for the y, well, we have an equation for the y. Y equals 80 minus 2 times 20, which is 40. Okay, so then we have 40 and 40 up here. And we can double check that all of these add up to 160. So 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. So those all add up to 160. And then the maximum area is going to be 80 meters squared. Sorry, 800 meters squared. So therefore, the dimensions are 20 times by 40, and the area is 800 meters squared. Okay, the integer question, 2 numbers have a difference of 10. So when I see difference, I'm thinking subtraction. So I'm going to have 2 numbers, say x and y, and when I subtract them, it's going to equal 10. So that means let x represent my first number, and let y represent the second number. Okay, find the two numbers if their product is a minimum. So product is when it's x times y, that's multiplication. Minimum is telling us that we have to find the vertex. Okay, so we can either sub in for x or y. Here's the thing, x already has a coefficient of +1, so I'm just going to move that y over. So it's 10 plus y. So I'm going to go ahead and sub that in for where the x is. Okay, and oh, you know what? This is already in factored form. So we can either, I would do it the factored route, or we can do it by completing the square. Okay, so if we want to do the factored route, since it's in factored form, we just set each of the factors equal to 0. This one's already done for us, and this one we would just have to rearrange. Okay, so we have 0 and -10, which means our graph is going to look like this. Oh, the product's the minimum. Maybe it's going to look like this. Okay, so what's the average between 0 and -10? Well, obviously it's -5. If we want to formally do that, we do 0 plus -10 divided by 2, which is -5. Okay, so we're going to take that -5 and we're going to sub it into 10 plus -5 times -5. So that's going to be 5 times -5, and I get -25. So the minimum here is going to be -25, and find the two numbers if the product is a minimum. So we have the minimum product, we need to find the other number. So we have x is, which is the first number, is -5. Sorry, this is y, because these are both y's, right? So then we have to solve for x. So x equals 10 plus -5, which gives us 5. So therefore, the two numbers are 5 and -5, right? And if you think about that, if we subtracted those, the difference would be -10, or the difference would be 10. And with a minimum product of -25. So if we multiplied those two, we'd get -25. Okay, height. A ball is tossed upward towards a cliff that is 40 meters above water. The height of the water in the ball is this equation, h equals -5t squared plus 10t plus 40, where h is the height in meters and t is the time in seconds. When will the ball reach maximum height? Okay, so we have this equation here, and we want to find the maximum, which is the vertex. Because this equation is in expanded form, I'm going to go ahead and complete the square. So bracket the first two terms, factor out the coefficient of t squared. Okay, so h equals -5, bracket t squared minus 2t plus 40. Now we take this number that's in front of the t, and we take it to the side of our paper, we divide it by 2, and then we square it. Okay, so we have h equals -5 t squared minus 2t. This number we're adding and we're subtracting inside of the brackets. Don't just cancel this out, we're using it to make our equation look a little bit different. Okay, so this -1, we bring it outside the bracket, and because it was in the bracket and this -5 has to be applied to it, we have to multiply the -1 by -5. Okay, so inside the bracket we have a trinomial, and then we have plus 40, and then plus 5 outside of the bracket. Okay, h equals -5. We're going to go ahead and factor this trinomial. So what two numbers multiply to 1 and add to -2? Well, -1 and -1. So x minus 1 squared, it should be t minus 1 squared, And then 40 plus 5 is 45. Okay, therefore the vertex is 1, 45. Remember, the 1 is opposite of what it looks like inside the bracket. So we can write a therefore statement saying, therefore, at 1 second, the ball reaches a max height of 45 meters. Okay, so now a revenue question. So just to recall, revenue has two brackets in when we create an equation. The price is going to be in one bracket, and then the quantity is going to be in another bracket. Okay, so a city transit system carries this many bus riders per day. So that's going to be in our quantity, 68.50. Okay, for a fare of 175. So obviously with the dollar sign, that's going to be price, 175. Those two numbers are like the base numbers where it starts. Okay. A survey indicates that the number of riders will decrease by 10. So the quantity is going to decrease by 10 for every 5 cents increase. So plus 0.05. Okay, I'm going to pause right there for a second. We're going to let X represent the number of price increases. And we're going to let R represent the revenue. Okay, because that's what we're going to use in here. So if we had 175 plus 5 cents, it would just be one price increase, but we need X number of price increases. And we're going to subtract 10, again, X number of times. So the question is, change colors, what is the maximum revenue that the city transit system will make, and at what price does this occur? Okay, so this is already in factored form, so I'm going to go ahead and set each of these factors equal to 0. Okay, so I'm going to bring this over, 175 equals 0.05x, and that becomes negative 0.05. Okay, so let's multiply 175, divided by 0.05. So I get negative 35 for this one. And on this side, I'm going to bring over the 10 and then divide out the 10, which is 685. Okay, so this graph is going to look something like this. 685, which is going to be way over here, and then negative 35. And our graph is going to go up and down. Okay, so this one's not as straightforward, like as to where the middle number is. So I'm going to formally say X is going to be the average of negative 35 and 685. And obviously divided by 2. So it's 650 over 2, which is 325. No, it's not up there. 325, there we go. Okay, so that's our X value for our vertex. Now, in order to find revenue and ticket price, okay, in order to find revenue, we have to sub it back into here. So when we use the revenue equation, if you think about it, the first bracket is actually going to equal what the price would equal, and the second bracket is going to equal the quantity sold. So if we had 175 and we increase the price 325 times, our actual price would be $18. Okay. As for the quantity, if we had 68.50 and we decreased it by 10 325 times, that would be 3,600 people riding the bus, okay, which would make $64,800 in revenue. So therefore, the max revenue is $64,800 at a price of $18.